Hey guys, we're up to 9D, which is planar graphs and Euler's formula. So we're looking at graphs or networks, they can be known as the other lesson, and I've got a few drawn here. But planar graphs are a certain type. So a planar graph is a network that can be drawn with no lines that cross over. So if we look at this one, we can see that none of those lines or edges are crossing over, so this one would be a planar graph. If we look at this one here, we can see that there are lines that cross over. However, we can also rearrange this network to look like this one here. And you might notice that with this one here, they're not crossing over either. So that would mean that this one is also a planar graph. The only way it wouldn't be a planar graph is if we rearranged it and still there was crossover like here, it wouldn't be planar. Now, we went over a couple of different key terms the other day. So we talked about vertices, which are these little sort of hubs here, and we talked about edges, which are the lines as well. The next thing we're going to talk about is faces. Now, faces are bound areas in a planar graph, so the graph has to be planar. So let's have a look at this one here. A face is a bound area. So can we see how there's one bound area here? So that would be maybe face one. There's a second bound area here, so that's the second face, and there's a third bound area here. So this graph here has three bound areas or three faces. If we look at this one over here, we've got one bound area and a second bound area there. So this one has two faces. Let's move on and have a look at Euler's formula. So it explains what it is down here, but Euler's formula is a rule that shows the relationship between the number of vertices, edges, and faces in a planar graph. And the rule's just here. So this is your main rule, but up here I've got written what it is, kind of expanded out in terms of it says what each of the letters mean. So the number of faces minus the number of edges plus the number of vertices minus the number of edges plus number of faces is always going to be equal to 2. So this is always going to be true for planar graphs. Okay, so planar ones. Not any one, planar ones. Now, let's have a look at these two examples here, and then we'll be done for the day. So for a planar graph, planar connected graph, find, I'm going to start off with B first because it's actually a little bit easier. Find F given that V equals 3 and E also equals 3. So we're going to use this rule here. So I'm going to rewrite it so I remember it, because if I keep rewriting it after each question, I'm going to end up remembering it without having to look. It'll make me faster. So I want F given that V equals 3 and E equals 3. Alright, so I'm going to change V to 3, I'm going to change E to 3, and I want it to find F. Okay, so 3 minus 3 is 0, so that leaves me with F equals 2. And there's my answer. So using Euler's formula, I found out how many faces this planar connected graph is going to have. Let's have a look at A now. So same thing, I'm going to use the rule to find out what E is. So V minus E plus F equals 2. I want you to do that every single time so you remember it. We're just going to put these values in. So it says we want to find E, V is going to be 4, and F is going to be 2. Alright, so we have, what I might do is move that 2 over the other side. So I'm going to take away 2 there, and if I do it to one side, if I do it to the other side as well, that leaves me with 4 minus E equals 0. I don't want a minus E here, I want a plus E. So if I plus E on this side, I have to do it to the other side as well, plus E. That means they're going to cancel out, and we're going to have 4 equals E. So we just worked out that the value of E is going to be 4 for a planar graph that has 4 vertices and 2 faces. And that's it for today's lesson.